Hi folks, this is Calc 3, Checkpoint Quiz 11. Number 1, we're given a function of two variables. We're asked to find and classify all the relative extrema. So when we're looking for relative extrema, we're looking for critical points. And we remind ourselves critical points are places where the gradient vector either zeroes out or the gradient does not exist. As we look at our friendly function f, it's a nice happy polynomial. We're not going to have to worry about these points. We're just going to have to worry about finding those points. So to that end, let's find the partial derivatives. Fx of xy. Take the derivative with respect to x, treat y as constant. So you're going to get 24x squared. This drops out minus 12y for fx, and let's look at fy. That's going to drop out. We're going to have 6y minus 12x. And we set this equal to 0, and this sets up a system of simultaneous nonlinear equations. So we pick one of these to solve, plug it into the other. This one actually we could use elimination on, but I'd rather just do it this way. I'm going to label this one equation 1 and equation 2. So I'm going to solve equation 2. I can solve that for y rather easily. Bring the 12x over, divide by 6. Y is equal to 2x. Substitute that back into 1. So we solve 2 for y. And we're going to substitute into 1. Give me 24x squared minus 12 times 2x is 0. So I can factor out a 24x out of all that. I'm going to get x minus 1 is equal to 0. So I get x equals 0 or x equals 1 out of that. Now, the nice thing about substitution, the substitution method, is I have an equation already solved for y in terms of x. And so that's what I can use at this point. So x equals 0, y equals 2x, so y equals 0, x equals 1, y equals 2x, so y equals 2. And so the long and short of it is I get two critical points. I get 0, 0, and 1, 2. So that's the critical points. Alright, so these were the critical points we found. And now to determine what's happening at those critical points, we apply the second partials test. So here's the first partials. We need all the second partials. So let's look at fxx. And that's going to be 48x. Fyy is going to be 6. Fxy is going to be negative 12. And if we've done everything right, that should be the same as fyx because these guys are continuous. Sure enough, it works out. So that's always a nice little check. So we find our discriminant or determinant d. That's fxx times fyy minus fxy times fyx. Let's see what we get out of that. We get 48 times 6. So that's 240 plus 48 is 288 x minus negative 12 times negative 12 minus 144. And so now what I do is I evaluate d at each of my critical points, and that's going to tell me what's going on there. Alright, so here's all the pertinent information. Let's look at the critical point 0, 0. Look at d at 0, 0. I get negative 144. And what's important about that? Well, it's less than 0. That means we have a saddle point at that location. Let's plug in the point 1, 2. D of 1, 2. Well, I plug in x equals 1. I get 288 minus 144. That's 144. And what's important about that? That's greater than 0. So since that's greater than 0, I now look at what's going on with fxx. So fxx at 1, 2. Oops, if I could, once again, if I could write fxx at 1, 2 is 48. And that's also bigger than 0. So you put these two facts together, that means we got ourselves a relative minimum. And so that'll do it for part A.